Question 19 is about upper and lower bounds, and we want to firstly write down the lower bound for p. Well, if p is given as 4.3, that means it's been rounded to the nearest 0.1. So how big could it have been? Well, it could have been 4.31 because that would round to 4.3. It could have been 4.32, 4.33, 4.34 even, because that wouldn't change the 3 if you had to round it to one decimal place, or two significant figures. Could it have been 4.35? Well, this is where you really have to think about upper and lower bounds, because normally if you had to round that to one decimal place or two significant figures, then you would call that 4.4. But here's something to think about, and this is a calculator paper, so if you have your calculator at hand, if you type in 4.349 and just keep doing lots of nines, then some of you will probably think to yourself, well, hold on a minute, that's just about as good as saying 4.35. And for upper and lower bounds, when you have something to the nearest 0.1, what you do is you split the 0.1 in half, and you can do that on your calculator. So if you take the 0.1 and divide it by 2, you can have 0.05 one way and 0.05 the other. And all you have to do to find the upper and lower bound is take the number you started with, in this case 4.3, and then you can add 0.05 to it to get 4.35, and that would be the upper bound. And then you can take the number again, 4.3, and take 0.05 away, and in this case you'd get 4.25, which would be the lower bound. So that's where the confusion generally lies, because students think, well, hold on, if I write 4.35, surely that rounds to 4.4 to one decimal place, and that wouldn't be allowed. But if you think about this situation here, if you wrote 4.34 and put loads of nines at the end, in fact you could never stop because there'd be an infinite amount, that's as good as 4.35. Okay, so that's the upper and lower bound situation. So for part A, write down the lower bound for P. Well, that's okay, we're just going to write 4.25. Now we've got to look at part B, and that's a little bit more complicated because we've got this equation here. We have R equals P plus 1 over Q. And it says work out the upper bound for R. All that means is that you have to maximize R and make it as big as you possibly can using the rounded values for P and Q. So first of all, you definitely want this to be as big as possible, wouldn't you? Okay, because R is to do with P plus something else, which we'll come to in a minute. So we want P to be its upper bound. So let's have a look. P, its upper bound, well, that's 4.35. So the R maximum that we've got, that we want for the question, is going to be definitely 4.35. Now here's the thing which makes this question the grade that it is, because it's approaching the A star. It's more at the grade A for me, but it's at the higher end of the GCSE, definitely. If you think about this fraction as cakes and people, if you want this fraction 1 over Q to be the most it can possibly be, i.e. you want to go to this place, this party, and have the most cake you possibly can, then if you've got one cake and you want the most, well, surely you want the least amount of people to show up, because the smaller amount of people that show up, the more cake that you'll end up getting if it's split equally amongst those people. If there were loads of people turning up and only one cake, then you'd get a lot less, and 1 over q would be the least. So to make 1 over q the most, you've got one cake, i.e. the numerator, and you want the least amount of people to show up. So you want q to be its lower bound. Now, as q was 0.4, and that also was rounded to the nearest 0.1, then you do this little thing, you take the 0.1, which is what it's rounded to, you split it in half. In fact, that's always the case. You always, whatever it's rounded to, you always split that in two, and then you add to make it the upper, and you take it away to make it the lower. So we want q to be the least, so we want to have 0.4, and we want to take 0.05 away from it, and you should on your calculator get 0.35 for q. So we've got 1 divided by 0.35. Now I'm going to do that on my calculator now and see what we get. So we're going to have 4.35 plus 1 divided by 0.35, and my calculator says 7.20714,285, and I believe that that's going to be recurring, this part here. It doesn't really matter if you spot that or not. Now, what would we give our answer to? That's the first thing to think about. Well, in the question, we were using numbers to 3 significant figures here. So I'm going to leave my final answer to 3 significant figures, so I'm going to write 7.21 here. Okay, so 7.21, and I'm going to write 3SF in the bracket there. Okay, so quite a tricky question. Question 20, in my opinion, is a very difficult question. I would find this difficult to do if I was doing this exam. So having not seen this question before, it's going to be quite difficult for me to explain straight off, but I'll give it a try. There's 2 watch faces, and there's 2 different types of material. So one is plastic and one is metal, and it tells you that the ratio of cost between the metal and the plastic is 3:2. So I would say that's definitely something worth writing down. So metal to plastic is 3:2, and it's about cost, so I guess we could put a pound sign there. So that's definitely something to write down. So face A is made entirely of plastic, and it says about the materials have the same thickness, so I think that takes out the idea of doing volume, for example. It's independent of the width. Okay, so we're just going to look at the surface area. So if we look at watch face A first, so let's have a look. So watch A, then the surface area is just pi times the radius squared, and if you've got a calculator you could start to decimalize this, but I'm just going to do it without a calculator. You can do it with, it doesn't really matter. We're going to get the same answer at the end. So that gives me 4 pi, and that's in centimeters squared. Watch B, now you've got to be careful here, and it says 20 degrees sector is of metal and 340 degrees of the sector is plastic. Now the way I do this, if I write a little m there, then at least we know that that part there is metal and this part here is plastic, so we don't get confused. So we know that all of this watch face A was plastic, so I'm going to put a P in there so we don't get lost with our workings. So let's do the plastic part of the watch face B. Well, it's going to have 340 degrees out of the 360 as a fraction of what the area would have been. And the radius is still the same. So what we can do is, again, you can do this with calculator. I'm going to do it by hand if that's okay. So I'm going to divide top and bottom by 10, and then I'm going to halve the top and halve the bottom. So I will get 17/18 of, and this is going to be 4 pi. Then I'm going to halve the bottom and halve the top, and that's going to give me 34/9 of pi, and that is going to be the plastic part. Now if I want to look at the metal part of face B, then I'm going to have 20 out of 360 degrees. That's what the fraction of the whole surface area is going to be. So it's the same procedure again. Divide by 10, divide by 10, halve the top, halve the bottom. So I'm going to get 4 pi on top, 18 underneath, halve the top and halve the bottom, and I'm going to get 2 pi over 9, and this is going to be the metal part. Now I think this ratio makes a lot of sense, because if it's £3 for metal for what £2 is for plastic, then we may as well just keep £3 for metal, £2 for plastic. What I mean by that is we could say £30 for metal and £20 for plastic, or even 300 to 200. But if we keep it as simple as possible, because at the end of the day we've got to work out the ratio of cost of the materials for A, i.e. for making the whole of the watch face A as opposed to the whole of the watch face B. Now let's see if you can understand this. So let's have a look at the cost now, and I'll make a little bit more room here. So we're just looking at cost now for A. So we have 4 pi, and I should have written this P here. So for plastic, now we're saying plastic, don't forget, looking at the ratio, what we had before, the plastic is going to be £2 and the metal is going to be 3. Okay, so wherever we see plastic, we're going to put 2. So we're going to put £2 there. And then if we look at the cost of watch face B, we're going to have our 34/9 of pi, and then we see plastic, so we're going to have £2 there, and then we're going to have the metal part, and that's going to be £3, don't forget. So if we look at those costs in the simplest form, so we can say that for 4 pi centimetre squares, say that has a cost of £2, then how much is that going to cost? Well, it's going to be 2 lots of 4 pi, so that's 8 pi pounds for the cost of A. And if we look at the cost for watch face B, and don't forget, we'll just keep it in its simplest. We could have put a 20 here, and that means we'd have to put a 20 here and a 30 here. The ratios would all cancel down, but we're just keeping it in its simplest form. So we've got 34 times the 2, which is 68 pi over 9 pounds, plus here 6 pi over 9 pounds. So the cost here stays the same, nothing can be cancelled there. But what about this? Well, we have a common denominator of 9ths, so let's write that there. And we're looking at pounds, and then we have 68 and 6, which is 74 pi altogether. And that's now a ratio, but we want that ratio in the simplest form possible. So I'm going to times both sides by 9 to get rid of this dividing 9 here. So I'm going to times both sides of my ratio by 9, and that's going to give me 72 pi pounds to 74 pi pounds. Now I don't need to have pi in here, and if you were using your calculator you'd have some strange decimal, and if you divided both sides and to try and make them nice whole numbers, then you would end up with 72 to 74. Basically, I'm going to divide both sides here by pi, and that's going to give me 72 to 74, and then I can see that they're both even, so I'm going to halve both of those, and that's going to give me 36 to 37. Now I'm going to drop the pound sign because when we've got a ratio we know it's about cost, so we can just have that here and we can talk about the cost, but we'll give our ratio as 36 to 37, and that's what I would do for this particular question. If you were to do it the calculator method, then you'd end up with these particular figures on your calculator here. And what I've done in this case is given you an opportunity to find a unitary ratio. So you could say for every pound, by dividing left and right by 25.13274,123, you'd have for every £1 spent on watch face A, you'd have to spend 1.027 recurring pounds on watch face B. Or you could go from here and say for every £25.13 you spend on watch face A, you'd have to spend £25.83 or thereabouts on watch face B. But I hope you can appreciate that if you start using the calculator for this type of question, it's going to be really hard to find the numbers as integers, i.e. whole numbers like this. So you don't have to do as much cancelling as I've done there, okay, throughout the question, but you really should be able to narrow it down to nice whole numbers, because it's this pi here that's the difficulty, because as soon as you type that into the calculator, then you're going to have some difficulty. So I guess one other way you could do to make things easy for yourself is to maybe go back to here and just get rid of the pi straight away by dividing both sides by it. And you can do that here as well. You can say, well, I'm going to divide by pi both sides and then cancel it all the way through. So then there's probably less temptation to use the calculator and get some horrible decimal that goes on and on forever. Okay, so that's just a little bit extra there. If you don't want to hear that, then just skip forward and we'll go on to the next question. Question 21, it's got a two-way table based on how each student went to the aquarium or the Brighton Wheel or the Royal Pavilion in Brighton. Now, the teacher's got to take a sample of 40 of these students. So I think the first thing we should work out, and you can do this on your calculator, let's work out how many we've got here. So in the first column, it's 52, the next column, that's 50, and then we've got 46, so 148. So we've got 148 students altogether, and you've got to take a sample of 40 of these students, so don't worry about that, but you've got to do it in a fair way, in proportion, and that's what stratified means. And it says here you've got to work out the number of students that were taken from the sample who are female and went to the Brighton Wheel. So there we go, there they are. So if you had to take students from each of those parts, like males who went to the aquarium, females that went to the Royal Pavilion and so on, you would just take the number, and in this case we've got to look at females who went to the Brighton Wheel. So we take our number 35, we look at it in proportion to how many of the total students there are. So that's what fraction we need to take of the total sample, and it's as simple as that. So on your calculator, because I can't be bothered to cancel that down right now, we're just going to do 35 divided by 148 and then times it by 40, or you could do 35 times 40 and then divide the answer by 148, it'll be the same, and I get 9.459, and 459 and so on, because there's a little dot here and a here, which means the 459 recurs. So what I then do in that situation when I do questions like this is that I will look at it to the nearest whole number, and in this case to the nearest whole number it would be 9. So just for those that were wondering, say you wanted to know how many males there would be, you would just do 16 divided by 148 and then times that by 40, round it to the nearest whole number, and you would get 4 and so on. Okay, now they won't maybe every single time add up to 40, you might just be one out here and there if you add them all up together, but don't worry too much because the examiner knows that you understand what's going on, and a sample hasn't got to be perfectly accurate because there's always going to be rounding involved. Okay, but in this case 9 students would be absolutely fine. Question 22. Well, I haven't seen this type of question for a very, very long time. We've got to try and work out the quadratic equation from the solutions for x. So if we just jot that down. And all we have to do here is to try and work backwards, I would say, to try and get the quadratic form. So I may as well just try it and see what happens. So let's times both sides first of all by 4 to get rid of this denominator here. So that would give us 4x equals -7 plus or minus the square root of 49 minus 32. I think for starters we can definitely sort this part out. So we'd have 4x equals -7 plus or minus the square root of 17. Then what we could do is we could add 7 to both sides, and that would give us 4x plus 7 equals plus or minus the square root of 17. Now one thing to think about is, don't forget, if the answer was plus or minus 17, plus or minus the square root of 17 rather, what would be the question? Well, it would be the square root of something, wouldn't it? So the next thing to do would be to, not do that, it would be to square both sides. Okay, so that's what I'm going to be using to signify that we're going to be squaring both sides. I'm going to carry my working up here. So we would have 4x plus 7 squared, all squared, would be equal to, well, if I had an answer of plus or minus root 17, what would be the question? Well, if I was to square that, I would just get 17. Now, what have I got in this situation? Well, I've got 4x plus 7 all squared equals 17. So from here, I can multiply out the bracket on the left-hand side, and let's see what we'd get. You can do a little grid up here. So we'd have 4x plus 7 multiplied by 4x plus 7, and we'd get 16x squared, 28x, another 28x, and 49. So 16x squared plus 56x plus 49 equals 17. And then last but not least, we can take 17 off both sides, and that would give us 16x squared plus 56x plus 32. Now that would be equal to 0, and we can then halve everything, and we would then get 8x squared plus 28x plus 16 equals 0, and we could halve everything again. That would give us 4x squared plus 14x plus 8, and then we could divide everything by 2 again, so we'd get 2x squared plus 7x plus 4 equals 0. So I wanted to do that step by step. I didn't want to go straight from here to here by dividing everything through by 8, because I might have lost a few people doing that. You can just mess around with it and just see, well, they're all even. So if you get a situation where you get even, even and even, you can just halve if you're not sure if you can see it straight away. Just halve. If you get even again, halve again, and so on. If you can see it all in one go, then brilliant. So 2x squared plus 7x plus 4 equals 0. Now, with this question, I've just thought that the way I did it was probably really not the way that most people would have done it at all. And it's just crossed my mind there's probably another, maybe easier, well, there is definitely an easier way of doing it. So I've got to give that a try. Or most people are going to think this is a terrible question. So if we have x equals minus 7 plus or minus the square root of 49 minus 32 all over 4, I just want to compare that with minus b plus or minus the square root of b squared minus 4ac all over 2a. So we can see here, for example, that the 2a is 4. So if 2a equals 4, then a equals 2, which was what we had here. And we can see that the b squared part is 49. So if b squared is 49, then we could deduce from that that b is plus or minus 7. Okay. Now, in this instance here, if you look carefully at these two parts here, we get minus 7 is the same as minus b. So b would have to be 7, not minus 7, because if b was minus 7, then minus b would be minus minus 7, which is 7, and we don't have that here. Okay, so we know that b would have to be 7. That's exactly what we got here. So what do we need to find last of all? Well, we just need to find the value of c. And if we look carefully at this part here, we see that 4ac must be 32. We already know what a is. A is 2. So we've got 4 times 2 times c is 32. So 8c must be 32. So c must be 4, which is 8 times smaller than 32. And that's what we got here. So I'll be very honest with you, I wouldn't have done that in the exam. I'd have just worked it through like I did first time round. But that's just the way I've done it. I've not seen these questions before. I certainly don't practice them, and I just do them straight off. But I guess that's another way of doing it, and you can choose whichever way you like. You have the formula, this formula here, in the formula part of the exam booklet at the very front, so use it, I guess. Okay, so that's that question done.